So I am going to post the exam today. I haven't made it yet, I just have a draft, but it will be available on Canvas by midnight tonight and then due a week from today. I need to check the date. Actually, we said extra time, so we're going to go
next week, a week from today.
I think we're going to add a few more days. Let's do the 15th, which is Thursday. Okay. So the first thing we'll talk about is the topics on the test. And then do examples. But for today, we're going to do just chapter 16. And on Thursday, we'll go over chapter 17. Okay. First. Okay, let's get it. So this exam is on probability. I started off with a reminder of what a sample space is and what an event is. So sample space we call S. Okay. So probability is the measure of likelihood that an event will occur as the result of an experiment. So sample spaces are all of the results from all possible results out of your experiment, and we call the results outcomes. All possible outcomes.
Professor, I just have a general question regarding exam 2. Will it be, I mean, of course, since exam 2 covers more chapters than we had in chapter 1, is it still going to be like the like a general number of problems, but worth more points? Like, you know how last exam was like, I think 15 questions and the total was it 90 or 100 points? So will they have a greater multiplier than like the homeworks do?
I think it'll be kind of the same number of questions as the first test. Yeah. Probably the same number of points. Not a big.
Cool. All right, thank you. It's one, but yeah.
That's a good question. I'm going to actually put that note to myself and this one too. Okay, all right. Event is any subset of your sample space. And then we're going to put down the definition for probability. A be an event? The probability of A. It is written like this, equal to probability of A, and then close the parentheses. That is equal to the number of outcomes in A over the total number of outcomes in S. Divided by that total number of elements in S, or outcomes in S. What's next? We're going to save examples for after the list. So we're going on to the complement rule. Okay, the probability of A complement is 1 minus the probability of A. We did an addition rule. We talked about disjoint sets, and we're not gonna test on conditional probability. So that's the last of it. So, complement rule, addition rule. Is for the probability of A union B. It's equal to probability of A added to probability of B, subtract the probability of A intersect B.
And the reasoning behind that subtraction is because the middle part doubles up what A and B are together, right?
Yeah, exactly. Let's write it below. Okay. Rule, disjoint sets. Okay. The sets. A and B are disjoint. If they share no common elements. So their intersection is empty. After that, we did the conditional probability, but it's not going to be on the test. And that should be it for chapter 16. Double check. Okay.
Sorry, Professor, I'm kind of the guy with a million questions.
Oh,
One last thing I want to confirm with the disjoint sets in the terms of, I guess, applying that. Basically, I just want to remember correctly that if there's nothing in A intersect B, A and B, then that means they're disjoint. Like if that the middle part is 0, or not 0, but have nothing in them.
exactly. Yeah. This means A intersect B if A intersect B is empty. Yes. Let's see. And we'll draw a picture and then we'll do examples. Okay, so like if you can draw the picture this way with nothing shared in the sets, then they're going to be disjoint. But if they have something in common and they have to be overlapping so that you have that shared element, they're not disjoint. Okay, so you've got like A intersect B and it has some element inside we're going to call X. Okay, so it's not disjoint. They have to have that little shared spot with that shared element. So we're going to do examples like the first homework, and let's see, I've got four examples with a lot of pieces to them. So the sample space is the set 1 through 9. A is the set that contains 4, 6, 8. B contains 9. Okay. We're going to draw a Venn diagram just for a good visual of the problem. we have the full space, S. The sets A and B, I am going to draw them overlapping just in case. 4, 6, 8 will be here, 9 over there, and the intersection is going to stay empty. So 6, 8, 9. So outside of those sets, we'll put 1, 2, 3. We've got 4. We need 5, 7. 5, 6, 7, 8, 9, and that's all of our outcomes. Are A and B disjoint? A and B are disjoint because they share no common outcomes. Okay, I'm gonna erase this picture. I have a copy, so we'll just be talking about the pictures sometimes, but also we can use some of our rules. All right, so this one is since they share. Our outcomes. Next part, we find the probability. Actually, we'll just continue to find probabilities. Okay, find the following probabilities. So this is part C, number 1. We find the probability of A. So those sets are disjoint. Another way to say this was the intersection is empty. So for this probability of A, we need the number of outcomes in A divided by the number of outcomes in S. Set A has 3 elements inside, and the full set is 9 elements total. One, two, three, 5, 9. And for your test, it would help if you simplify the answer. Fraction or decimal is fine, but oh yeah, and that's the question we got. Cool. And if you forget to simplify, it's okay. As long as the answer is correct, it just helps me to grade the problems faster if you reduce. So about 1/3, And now we get the probability of A complement. This one, I'm going to use the rule. Take 1, subtract the probability of A. And I'm going to use this simplified version, 1 minus 1/3. Okay, I can rewrite 1 as 3/3 and then subtract 1/3. 2/3. Okay. Number 3, the probability of B. So find the number of outcomes in B, divide by the total number of outcomes in S. Look at my picture. Oh, there's only one outcome. Okay, so there's one element in that set B. And there's 9 elements total, or 9 possible outcomes. It's going to stay like that. Find the probability of the complement of B. B complement. I'm going to do 1 and subtract the probability of B. That complement. 1, take away 1/9. I would write 1 as 9/9, and subtract the 1/9. Get 8/9. Few more. So number 5, probability of A intersect B. So we're going to write out, it's the number of outcomes in A and B, this set here, this set right here. Total number of outcomes. From the picture, you can see the intersection is empty, and we'll also write it on the side. Maybe we'll put it down at the end. Okay, so A intersect B has no elements, which is going to be 0. Number of elements in that set divided by 9 total outcomes. So we got 0. We're going to write down what A intersect B is, just to make this clear. A intersect B is the empty set, which is the set that's just brackets. Okay. The last one is to find the probability of A union B. Number 6. Yep. So you could find the set A union B, but instead I'm going to use the rule. We're going to take probability of A, add probability of B, and subtract probability for A intersect B. Also, these are disjoint sets, so this here is going to be a 0. Let's put that in right now. And just going to have a -0. That right there. Probability for A was 3/9, and then the probability of B was 1/9. And we're subtracting 0. So just this part here where we need 4/9. Okay, so we're going to create a new sample space and go through all the same steps. So this set starts with 0 and then goes up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just count it out right now. So if you count these elements, there are 10 total. We need sets like A and B. We'll put A equal to the set that contains 0, 3, 9. B contains 1, 2, 3, 4, 7. We're going to draw a Venn diagram for the first part. Part A. I think this picture can fit on the sign. put the full space right here, S. A and B are going to have an element in common. They definitely share 3. That's it though. So in the middle of A and B, 3. Put 0 and 9 in the set A. 1, 2, we've got 3 already. 4, 7. And don't forget any other elements. So we've got to put 1, 2, 3, 4, 5 on the side. 6 somewhere else. 7, 8. Outside. And then 9. Okay. Find, oh, actually, are A and B disjoint? A and B are not disjoint since they share the element 3, or they share a common element. And then another way to write this, and you don't have to write both parts, just this part would be fine. But another way to say it is to say they are not disjoint, comma, A intersect B does not equal the empty set. So if the intersection is empty, then they're disjoint. If it's not empty, not disjoint. Part C, we're going to find probabilities. Probability term. Start with probability of A. So find the number of outcomes in A, divide by the number of outcomes in S. I remember that S had 10 elements inside. And A has, let's see, 1, 2, 3 outcomes. You could leave it like, fraction form is fine. We'll leave it like that. Probability of A complement. Use the complement rule. Take 1, subtract probability of A. 1, subtract 3 out of 10. So we have 10 over 10 minus 3 over 10. Got 7 out of 10. squared. All right, next, probability of B. The number of elements in B and divide by the number of elements in S. There's 1, 2, 3, 4, 5. 5 elements in B. 10 elements in S. Probability of the complement of B. Take 1, you can subtract probability of B, and then simplify. I'm going to use this reduced form. So take 1 and subtract 1/2, which is 1/2. But just in case for practice, 1 is 2 add 2. Take away 1 add 2. Use 1 add 2. Okay. We'll do the probability of A intersect B, the probability of A union B, and call it good. Probability A intersect B. So we find the number of elements in A intersect B, and there's 1 element. Double check my picture. One element out of 10 elements. So last part of this example is find probability of A union B. I'm going to use the rule. Probability A, add probability B, subtract probability A and B. All right, let's go to the set A, which had 3 elements. 1, 2, 3 out of 10. Add. Our set B has 1, 2, 3, 4, 5 elements. A intersect B had 1 element. So 3 plus 5, subtract 1, all over 10. So we're going to get 7, 5, 6, 7, 8, take away 1. Okay. We're going to do 2 examples based on data tables, and that should be it for this review, this part of the review. Example 3. Consider the following data table. So this side will have x, y, the top will be a, b, and then we'll put the totals. So x, y, total. A, B, total. So A and B are events, X and Y are also events, and the totals are just extra information for us. So these are sometimes left out of the picture. Okay, in this part is 10 and then 5. We're going to put 20 and 0. Across, we'll have a total of 15. The total for Y is 20. The total for B is 5. And the total for A, 30. Okay, the total for the whole set is 35. And you can double check going this way. We have a 5 and a 3. That's good. And this is the place where you have that number of elements in S. So this. So putting total number of outcomes in S. Find probability of A. Let's see. We're going to do. We'll call this number 1. So for number 1, B of A. Let's see. Probability of A is the total number of elements in A, which is 30, divided by the total number of elements in S, which is 35. Find the probability of, let's wait for a moment to do that. It's going to go probability of X. For this one, we find X and get its total. So total for X is 15. And then the probability is 15 out of the number of elements in S, 15 out of 35. We will do the probability of the complement of A. So this is number 1, this is number 2, this is number 3. And use the complement rule. So take 1, subtract probability of A. No, I'm going to leave that. Yes. Okay. Probability of A complement is 1, subtract probability of A. Take 1, subtract 30 over 35. And we'll work it out. So 35 over 35 minus 30 over 35. 35 subtracts 30, leaves 5 in the numerator. And divide by 35. We can reduce that. Let's keep on doing scratch work. Okay, 5 over, what is this? 5 times what? 5 times 7? Looks right to me. Okay, reduce down to 1 over 7. Awesome. Let's find the probability of B complement. And what I'm going to do, because we need some more scratch work, some more space to do scratch work, is redraw this in just a bit. So we'll come back to this table soon. Awesome. This is 1, 2, 3, 4. Cool. The probability of B complement is equal to 1, and then subtract the probability of B. Take 1, subtract. 5 out of 35. That total for B out of the total for S. And we can work it through this again. 35 over 35 is 1. So 30 out of 35. So I think I can put the table maybe over here, and then we can keep on working through problems on the side. Ten, 20, 30. 5, 0, 5. 15, 20, 35. Cool. Next problem. Find the probability of A intersect B. Oh, sorry. A intersect X. P of A intersect X. Actually, that one we can just put down. So find the set A. And where it overlaps with the set X. This way. What's this value here? A intersect X is 10. So the probability is to take 10 and divide by 35. Cool. Find, next page. The probability of A intersect Y. So this time you find your set A. And then where it overlaps with Y. Let's do. So this time we're looking at 20. And then for probabilities, you take that number, divide by the total, which is 35. All right, we're going to do the probability of A union X. It's the addition rule. For probability of A, add probability of X, subtract probability of A and X. Okay, one moment. And I'm also going to double check the time because it feels like I don't want to go over time. I need to wrap this up a little bit.